We are constantly ordering and reordering objects. In computer science applications, orderings of objects appear in different scenarios. For example, when you are looking up the places you want to visit, or when you are simply looking up something on Google. So we need to study the probability distributions on permutations. A very natural probability distribution that is defined on the set of permutations is called the Mallows model. In the Mallows model, we have a center, and the probability of a permutation goes down when its distance with the center goes up. The distance is defined as the number of inversions that we need to make going from one permutation to another one. For example, in this example, we have to make 3 different inversions, so the distance is 3. The problem is the full rank is studied a lot, but it's not really used. In a lot of real applications, we have billions of objects, but the users only read the top K. So in our paper, we suggest that instead of studying the full rank permutations, we need to study the top K lists. So we change the definition of the Mallows model by changing the definition of the distance. We give different weight for the inversions that happen inside a center and for bringing in the objects that are outside the center. The inversions that happen outside the center are free. So now we have a formula and we want to generate data from it. This is called sampling. When you have a formula and you want to generate data, we propose 2 different sampling algorithms. One of them is dynamic programming and one of them is Markov chain based. Then another scenario that happens is that you have the data and you want to learn the formula. So we consider this problem in 2 different scenarios. One is when you have one single center, and one is when you have different centers and your data is a mixture of data generated from all of these multiple centers. We run our algorithms, we choose some centers, we run the Markov chain to generate data, and then we run the reconstruction algorithm to reconstruct the center again. Then we go to this website on which the top K favorite movies of different important people in cinema are listed, and then using our algorithms, we reconstruct the top K center of the best movies of history. If you want to learn more about our results, please read our paper.